Woohoo, we are live, and this is a video all about solving word problems, but this time we're going to do it with systems of equations. So in the past, we have talked about word problems or applications that you can solve using a single equation, but now we're going to be using two, or in fact more, although spoiler, we're just going to use two for this video, but you could use as many equations as you'd like. And in fact, fun fact, generally speaking, you need an equation for every single variable. Not entirely true all the time, but a lot of the time it's a good idea. So let's talk about some basic word problem strategy. So the first thing that we're going to recommend, that I am going to recommend, even though sometimes I cheat it a little bit, is definitely read through the problem. Make sure you've read all of it, just in case there's any sneaky surprises at the end or something interesting going on in the middle. So read through the whole thing, but just read through it one time. Then you want to ask yourself, is this a word problem I've worked with before? Does this follow a familiar pattern? And if so, do I have any formulas I need to remember to use? So the first thing you're going to gather, basically you're going to gather intelligence about this word problem. What is it? Have you seen it before? Any variables? Any formulas? Sorry. Second, if you can, I encourage you to draw a picture. Now you notice it says draw a picture. As you can see, I drew pictures. I drew my Sharktopus and I drew my Godzilla, and they keep me company and they keep me calm. So if you find yourself panicking, take some deep breaths, draw a picture of anything you like. However, if you want to stay on task, draw a picture that describes the situation. In this very first problem that we're going to talk about, we are going to talk about a rectangular garden. So I will draw a picture of that. Number 3, read the final question to set up the variables. This is a really big hint. A lot of people try to figure out what the variables are using the beginning of the word problem, which is sometimes possible. But frequently, if you read the last sentence or the last question, depending on how it's phrased, for example, find the dimensions of the garden, that's going to be our key for this one. So that's how we know which variables we're going to use. And lastly, we want to look for any numbers. So like in this first one, I see the number 150. I also see a sneaky number. It's not written as a number, it's written out as words, but it says 1/2. That's also a number. So the last part of it is to identify all the numbers and make sure that either you're using them, or sometimes the numbers that are in the word problem aren't going to be useful at all. So just make sure you've seen all the numbers and you know whether any of them are useful. Okay, let's go ahead and get started. Woohoo! Put this over here. Put this right there. I also have lots of colors because they make me happy. I would encourage you, these are going to be long videos because this is word problems and I've got 5 or 6 examples to go through. Make sure you have something to drink, stay hydrated, some energy foods or snacks or popcorn or something, or vegetables. I'm sure vegetables are really good too. Or, have, a little city to munch on, maybe a yacht or an airplane if you're Sharktopus. Okay, so shall we get started? We can totally do this. Let's do this. Okay. Oh, and I forgot the other exciting part. Where is mine? There we go. Have your favorite calculator nearby because you never know when a calculator can be helpful. Okay. So my example, this is the first one. A 150-foot fence, I believe I should have hyphenated that, surrounds a rectangular garden. The width of the garden is 1/2 of its length. Find the dimensions of the garden. So this is a word problem that brings in a lot of different concepts. I'm going to ask my friends to move aside just a little bit. They're not going to go too far. They're going to stay here, close by, so I don't get too nervous. This is going to bring together geometry, So I've got a rectangular garden. It doesn't have to be beautiful, but it can be beautiful. If it helps to draw an actual garden, go for it. It's your time. So if you want to make it beautiful, awesome. So I've got a rectangular garden, and let's see, the width of the garden is 1/2 its length. That's an interesting line there. I think I'm going to underline that in yellow. The width of the garden is 1/2 of the length. There we go. That's telling me something interesting that I'm not quite ready for yet. I see another number. I'm looking for the numbers. 150-foot fence. Okay. And then lastly, right here at the end, find the dimensions of the garden. So we've got a lot of things going on here. And the number one piece of advice when you're doing word problems is read it, but don't fall into the trap of reading and reading and reading and reading. You need to have a way to pull away. Don't get caught in the spiral, because that's what anxiety does, right? It pulls you into the spiral. So try to step back. So drawing the rectangular garden is helpful. Let's see, it's talking about the width and the length. So I've got some ideas about the word problems. About the variables. Let's look here. Is this a type you recognize? Yeah, I'm thinking this has to do with geometry because it said rectangle. Are there formulas? I'm not sure. Let me hold off on that, because there are a couple of formulas about rectangles, like the area or the perimeter, but I'm not quite sure which one I'm going to use yet. Draw a picture, did. Read the final question to set up the variables. Final question, find the dimensions of the garden. So what does dimensions mean? Well, it means, in math, it means that you've got usually something that's rectangular or square. Sometimes it's a triangle, sometimes it's even a circle. But basically, you have to know what the dimensions are. In the case of a rectangle, I've got the width and I've got the length. Now, for your picture, you are welcome to label it however you like. I'm going to tell you that generally speaking, not always, but generally, the length is longer and the width is shorter. Is that always the case? No. And what could we do? Well, I could always turn this sideways and suddenly the width is on top instead of the length. So honestly, in this case for right now, it does not matter which way we're going to label it. It may be that later on in the problem, you decide to change it. That's okay. You can always cross out a picture if your first picture isn't helpful and draw another picture. But this is where we're going to start. Everything is not going to be perfect. A lot of word problems take some time to work through. So I've got the dimensions of the garden. Okay, so that's going to tell me I need variables for these, and I'm going to put them right here in the picture. For width, I'm going to do W. Now, length is tricky. You'll notice what I did there. I didn't do just a straight line L because that looks like a 1. So I'm going to use the kind of script or cursive L. And this comes from that last sentence or question. That's where we get that we're going to need those variables. Okay. And then look for numbers. Do they fit in formulas or equations? Well, I do have a number. I have a 150-foot fence surrounds. That means it goes on the outside. Now, if you're talking about the outside of something, you're talking about the perimeter. So the word surrounds means we're dealing with the perimeter. So I should probably know what the formula for a perimeter is. And I'll remind you that in a rectangle, if you start, you have to pick a corner, and then you go the length, you go the width, you come back along the length, and you come back along the width. So the perimeter is usually 2 times the length plus 2 times the width. Now, are there other ways to write this formula? Absolutely. Some people like to have the 2 out in front and the L plus W inside parentheses. Some people just have L plus W plus L plus W. Lots of different forms. Use the one that you feel most comfortable with. It won't make a big difference right now. Okay, so I've got the perimeter is 2L plus 2W. So this is my blue. This is the blue part of the question. It says surrounds right there. And so the perimeter is 2L plus 2W. So what is the perimeter? And it says that the fence that surrounds it is 150 feet. Now, normally, we don't put units into formulas. However, I'm trying to keep track of all the information I'm getting. So I'm just going to make a note that this is feet as opposed to meters. And I can always take it out later when I start to work out the problem. Okay, so I've used the blue part and I've used the purple part. See how underlining it helps me to see what still has to be dealt with. What has to be dealt with now is this yellow part. And I'm going to write it completely again. The width of the garden is 1/2, I'm going to write 1/2 as a number, of its length. So that is basically just the whole yellow sentence. Okay, so what can I do with this? Well, the width of the garden is W, translates as equals. Okay, the width of the garden, let me put this there. That's W. 1/2, already in math. And then 1/2 its length, that's 1/2 times the length. That's a little tricky, and that's something you're just going to have to kind of work out. Sometimes English and math don't mesh up perfectly as languages, but when we say 1/2 its length, we mean multiplication. So I've got a picture. I've got my variables. Now, one thing to be careful of, if you're in my class, I'm okay with you declaring your variables as part of a picture. There are some professors and teachers who would like you to write this in a separate place. Somewhere on the paper, you would write, I'm going to write right here because this is where I've got room, declaring the variables. And you would say let, that's a big fancy word in math. It says I'm about to tell you the assumption I'm going to make or the definitions I'm about to give you. W is the width and L is the length. And I haven't made it very fancy. Of course, you can make that much fancier. In some classes, you have to declare in full sentences. So, follow whatever the guidelines are for your particular class. Again, in my class, I actually don't mind when people declare as part of a picture, as long as the picture is pretty straightforward. I can see the rectangle. I know what the person is saying. So, okay, let's move on. So what I said in the introduction was that these are going to be problems where we're not just looking for one equation, we're looking for two equations. So you'll notice we've got the blue equation, 2L plus 2W equals 150. That's the blue information right here. And then I also have, notice I left out the feet because when we start to get into the math, you don't include the units. And then I've got this other equation, W equals 1/2 of L. Okay, so the width is half the length and the perimeter is 150. And these are part of the same problem, so they are simultaneous equations. This is a simultaneous system of equations. Okay, once you've got equations, you really want to ignore everything else. Pretend it's not even there. Focus on the equations. It is very important not to get sucked into this part. However you take notes, you want to get out of the word problem, you want to get out of these notes and get into solving this. So I'm going to take a look. I've got two equations. Now at this point, if you haven't studied systems of equations yet, this is going to be very confusing. So I encourage you to pause this, go back and look at systems of equations. Basically, we have two options. One option is elimination, and one option is substitution. I'm going to say, let's use substitution. Okay, so let me grab some more paper. Why did I choose substitution? Well, in this case, I've got one variable written out in terms of another variable. When you have the variables separated like this, they're not both on the same side. That's usually an indication that substitution is a good choice. Could I use elimination here? Yes, I absolutely could. It would take a little bit of work to set up, but I could do that. Could I use substitution always? A lot of the time you can, yes. Sometimes substitution is a better choice. Sometimes elimination is a better choice. I think in this case, substitution is the way to go. Sorry. And whistling. Whistling is also great. So here we go. I've got 2L plus 2W equals 150. And W equals 1/2 of L. I'm using my own personal rule. And this is a personal rule because my brain doesn't always tell me, it doesn't always give me the best advice and remember things quite as they are. My rule is when I'm transferring paper, I don't try to do any work in the middle. I just wrote down, and then now I'm actually going to take these two simultaneous equations and solve them. So I'm going to take my 2L plus 2W equals 150. And again, that one was the blue one. There we go. Blue. And then I'm going to take that W equals 1/2 of L, and I'm going to put it inside of the W. And this is what substitution looks like. In place of one of the variables, you stuff the whole, what am I doing? I meant to do this. That's going to be hard to read. There you go. You stuff the whole W equals 1/2 L. Where you see W, I'm going to put 1/2 L. So I now have this mega equation, kind of like a transformer, that has taken both of these equations and smashed them together. So if I multiply out now, I get 2L. So this part right there, this is the substitution. So then I've got 2L plus 2 times 1/2 L equals 150. But 2 times 1/2 L is just L. So I've got 2L plus L equals 150, or 3L equals 150. So 3L divided by 3 equals 150 divided by 3. L equals 50. Woohoo! Now that's not the only thing. If I have a simultaneous system of equations, I've got two variables. So that means I need to solve for both variables. There's the L. I want to solve for W. W equals 1/2 L. So that's 1/2 of 50, which is 25. Now here's the rub. It is possible to check your equations. So these guys up here, you can check your L and your W in the equation up here and confirm that the equations are correct. However, it is really hard to confirm that the equations are the right equations for the problem. So for this, I'm actually going to go back to my rectangular picture, and I'm going to think to myself, okay, the width is 25. And I remember this was measured in feet because I wrote this down. And I'm told that the length is 50 feet. Right there. And so let me go back to what the question asks. The question asks, it says we've got 150 feet of fence. Let me double check. If I start here, 50 plus 25 is 75, plus 50, 125, plus 25, 150. That works. Okay, so I've got 150 feet. Yep. And then the width of the garden is 1/2 the length. Is the width 1/2 the length? Oops, sorry. Is the width 1/2 the length? It is. So our W is 25 feet. L is 50 feet. And again, follow whatever the guidelines are for the class you're in. For the class I'm teaching right now, you don't need sentences, but you absolutely do need units. So make sure you've got the units in there. And just box it so it's easy to find. I already declared the variables, so anyone reading this will know what the answer is and what it means. And you guys are done. Woohoo! Yay! Okay, so join me in the next video. We'll do another word problem. Yay! Woohoo! Math on, guys. Math on.